in the values, the frictional force is 2000 Newton. Then mu minus mu, which is 0.36 times normal reaction, that is the force that is keeping the body on the horizontal plane, which is 1470 Newton, which is now equal to mass, which is 150 times acceleration, which we are looking for. Then we now have the value after the computation, which we now have 2000 minus 519.2, which is equals to 150 A. Then if we minus the values, we now have 1470.8 is equals to 150 A. Therefore, making A the subject of the formula, we now have 1470.8 over 150. A will now give us 9.8 meters per seconds. The body of mass 10 kg is hung over a pulley that will pull a body of mass 12 kg along an inclined plane at an angle of 30 degrees. We are asked to get the acceleration of the body of mass 12 kg and the tension and acceleration of the body pulling down the body of 10 kg and the tension. We also know that the mass of or the force of gravity is mass times acceleration for the body 10 kg, while that of acceleration due to gravity for the 12 kg body is mg sin theta, since it is acting on an inclined plane. Resolving the force for the body of mass at an inclined plane, 12 kg is being hung on a pulley by a tension T, where the acceleration A, which is unknown, along a horizontal surface mg sin theta. Force we know is equal to mass times acceleration. Tension of the body of the rope minus the force of gravity, which is mg sin theta, is now equal to ma. The tension on the rope minus 12 times 10 sin 30 is equal to 12a. That is mass of 12 times a. Therefore, T minus 60 is equal to 12a. T minus 12a is equal to 60 will be taken as our equation 1. Resolving the force for the 10 kg mass, we know that the tension T is pulling the body up, while that of the force of gravity mg will be greater to pull the body down with an acceleration of unknown acceleration. So mg, which is the force of gravity, will be greater than tension, which will be minus by the tension, will be equal to the force ma required to pull the body down the inclined plane. Substituting the values, putting in the values, we now have that 10, which is the mass, times 10, which is acceleration due to gravity, minus T, which is the tension, is equal to 10, which is the mass times acceleration. 1000 minus T, which is the tension, is equal to 10a. Then 10a, making the unknown values be on the one side and the known values to be on the other side, we have 10a plus T is equal to 100 is equal to 100. Now, solving for this will be our equation 2. Then using elimination method to solve the simultaneous equation of equation 1 and 2, we now minus the tension and now have minus 22A is equals to 4. Therefore, A is equals to minus 22A is equals to minus 40. Therefore, A is equals to 40 over 22, which will now give us 20 over 11. Then, putting in the value in equation 1, substituting back the value into equation 1, I have that T minus 12A is equals to 60. T, that is the tension, minus 12 times 20 over 11 is equals to 60. Therefore, T is equals to 12.5 plus 60, which we now have T. We now get our T to be 81.5 Newton. We can also get our acceleration. For only acceleration, F is equals to ma. We have that 100 minus 60 is equals to 22A. Therefore, our A is equals to 40 over 22. Question 14. A body of mass 10 kg is being hung over a pulley to be dragged up by a body of mass 15 kg down an inclined plane at an angle of 60 degrees. We are not given the acceleration, we are asked to look for the tension. Then, looking at resolving the force on the 15 kg mass on an inclined plane of 60 degrees, you now know that since the body of mass is greater and it is on an inclined plane, the body seems to be sliding downwards the plane, and the acceleration will be downward. Then force is equals to ma. The tension, which will now be greater than the force of gravity, which is mg sin theta, will now be minus mg sin theta to give ma. Then T minus 15 times 10 sin 60 will now give us 15, which is mass, times acceleration. T, which is the tension, minus 130 is equals to 15A. Putting the unknown values at one side and the known value on the other side, we have that T minus 15A is equals to 130. This will now be our equation 1. The 10 kg body is meant to be sliding up. We now have that 10, which is the mass times acceleration due to gravity, 10 minus T is equals to 10 mass times acceleration, which is unknown. That is 100 minus the tension T is equals to 10 times A, which is that acceleration. Putting the values of the unknown on one side and the values of the unknown on the other side, we have that 10A plus T will now give us 100, which is our equation 2. Using using elimination method to solve the simultaneous equation, we now have T minus 15A is equals to 130, or in bracket minus T plus 10A is equals to 100. We now have minus 25A is equals to 230. A is equals to 230 over 25, which will now give us 6 over 5 meters per second squared. Just know that the minus sign there means that the body is now weightless and it is now going up according to the question. Circular motion. Angular velocity phi is defined as the rate of change of angular distance with time t